Hi, and welcome to Magus Instrumentalis. This is Captain Kurtz speaking, and I'll be your tour guide here today through some of the Lovecraftian horrors we've got in the Madness Suite. So make sure to keep your patch cables organized and your fingers on the master volume knob because we're expecting some turbulence.
So before we get into it, let's explain a little bit about chaos. So chaos is a mathematical model that captures the spirit of how complex real-world systems like the stock market or animal populations or fluid dynamics tend to operate. All these systems are nonlinear, which means that the next state of the system depends on the current state of the system, kind of like feedback. So any small change on the input can add up to large and unpredictable changes in the output, which is known as sensitive dependence on initial conditions. So what does that mean for our modules? Well, both Nyarlathotep and Azathoth harness a three-dimensional chaotic system represented by the X, Y, and Z outputs. Nyarlathotep is a slower, low-frequency oscillator, where Azathoth is a quicker audio rate oscillator. So I'm plotting two of the dimensions here on the scope of Azathoth. So if we adjust this chaos knob, we're changing the position of the chaotic attractors, which will therefore change this sort of orbital pattern. So if I keep moving it, you'll see the pattern over here on the right change. So some positions of the tractor can lead to these stable, simple, periodic orbits. And some have more complex repeating structures. But if you keep pushing it, you can get to these unpredictable, evolving shapes that never quite repeat. And the same for Nyarlathotep. If we keep pushing it, we can find some modulating patterns that don't really seem to repeat, that continuously change. So remember sensitive dependence? That's why we have this fine knob right here. So it allows you to just slightly adjust the chaotic attractor, which allows you to get these really interesting midpoints between stable shapes. So we got a frequency knob on both the oscillators, and this just allows you to change the rate of the oscillations. And in the case of Azathoth, if we bring in the audio, it allows you to change the pitch. And both the attractor and the frequency have CV inputs. So let's, for example, get Nyarlathotep to control the attractor on Azathoth. So if we plug it into the mix here, the mix is just the sum of the three dimensions, and you can adjust the level of each dimension with its little own attenuator. So now let's bring up the modulation of Nyarlathotep on Azathoth. Now, because Nyarlathotep is in this periodic orbit, it sort of creates almost like a rhythmic pattern, which is really interesting. There's a lot of different nuances of these chaotic systems. This little switch here, parallel and series, allows you to chain multiple chaotic oscillators together through the attractor CV, and it's based on a system, chaotic audio system that professor and musician David Dunn used to combat bark beetle infestations. So chaos is the real deal, guys, all right? This sound made bark beetles not want to live anymore. So how can this be used in a musical context? Well, because chaos is like a metaphor for the unpredictability of the real world, you might use a little bit of chaos to perhaps frequency modulate an oscillator. If we follow the cable over here, this little bit of chaos can capture the ways that temperature changes on a circuit board can cause an analog synthesizer to drift in and out of pitch. So you get a very vintage tone there. Or maybe you want to model the liveliness of a percussive transient. If we bring in the VCA right here. You can get some really interesting percussive sounds messing around with Azathoth. Cool. There's a lot to explore here with chaos. So that brings us to Shoggoth, which is a super versatile module, which has way too many uses to capture in one video. But I'll give you the basics right here. I was using it in the last patch to generate some envelopes, and that's actually the first use case of Shoggoth. If you pass a trigger into the input, into the trigger input, then you can use it to generate an envelope that's based on the rise and fall that you've set with these knobs. So it's just generating an envelope. We can change the rise, maybe give it a really sharp attack and a longer fall. Even longer. Let's make it. Cool. All right, by messing around with the logarithmic exponential knob, we can change the curve of this envelope. So if you push it into the exponential direction, it'll have a sort of concave slope reaching the peak. And if we bring it towards the logarithmic, it'll have more of a convex or logarithmic curve. So you can see it's sloping upwards. And then if we change the symmetry knob, we can choose whether or not the rise and the fall have the same type of curve. So you'll see with the symmetry switch turned off, it has a logarithmic curve going up and then an exponential curve going down. And same for the other side. So that's what happens if you use the trigger input of Shoggoth. However, if I send a voltage in through the main input, like from this random module, it'll actually limit the rate of change of that voltage. You'll see it slowly approach the value instead of jumping directly to it. And we can change the rate that we want it to slope with. So now we can see that it jumps up really quickly with a fast rise, but it goes more slowly with a slower fall. And we can, and the linear and exponential curve still applies here. Let's really push it. So as a slew limiter, it can be used to smooth out modulation, maybe add some portamento slides into melodic sequences. And all of these inputs can be modulated by control voltage. By engaging the cycle mode, you can get it to continuously loop through its rise and fall stages. And we can use the knobs to change the rate of this rising and falling. So you can use this to generate maybe some LFO type modulation, but we can also actually push it into audio rates. So let's hook it up over here to so let's hook it up over here to the output, and you can see if we change the rise and fall, we can change the frequency of this oscillation. We also have the voltage per octave knob, which will offset this rate by 0 to 10 volts. So you really could use this as a oscillator if you'd like, and the linear and exponential allows you to further shape the curve. All right, and finally, the last two outputs, end of rise and end of cycle, will output a gate. Here, end of rise outputs a gate when it's reached its highest point, and end of cycle outputs a gate when the entire rise and fall stage end. And this way you can make maybe a clock multiplier or some more complex logic. And there's actually a lot of fun you can get by chaining Shoggoth modules together. We have some videos of that on Instagram if you want to see more. So right here we have the end of cycle of one Shoggoth going into the sample and hold input of another one. And this sample and hold is sampling this same little melodic patch we've got here. So let's turn that on. And let's bring up the Shoggoth down here. This is just a fun use case of this module. So if you can see right here, the blue is this end of cycle coming from the first Shoggoth. And what it's doing is it's telling this other one to sample this melodic sequence every time the first Shoggoth oscillates. And what that basically does is it sort of acts as a sample reduction of this sequence. So let's give it some fun. So you can use this sample and hold at audio rate values to get sort of an aliasing effect that's reminiscent of maybe vintage samplers or chiptune music. There's a lot of possibilities with this module. All right, now coming back to this main patch over here, we have Yog-Sothoth, which is a low-pass gate modeled off of early Buchla vintage synthesizers. And they're known for this organic pluck sound. But in general, this is just a great sounding filter. Let's turn up the VCA offset, which is the amplifier. So we're getting that same sort of warbly tone. This is a sawtooth passed into the filter. So there's a nice frequency sweep. We also have resonance control, which you can control with CV. Which gets that bump on the frequency spectrum right at the cutoff. Which is just a really classic sound. And we have drive, which allows you to further sculpt your sound. It allows you to get some more warmth out of the filter. And we can push the resonance into self-oscillation. Which is just super extreme there. So the characteristic sound comes from the use of this vactrol, which is an electrical component that places an LED directly in front of a photoresistor. So the brightness of the LED controls the voltage that can pass through. But because there's a slight lag with the photoresistor, it generates this plucky envelope. And I'll play that for you right now so you can hear what that sounds like. VCA offset is just the general amplifier there. The VCF-CV allows you to control the amount that the filter opens up, and vactrol envelope is the envelope speed. And you get different sounds too if you control the length of the gate that you pass in. I don't have it set up for that, but you should experiment with that if you have a chance. VCA in is, remember, it's the amplifier, so you can change the loudness of specific sounds. So right here we're getting it to sort of emphasize this last note of the sequence. And then this expression in is just sort of a master attenuation of both the VCF and the VCA. So it allows you to get more expression out of your sequences. All of this can be CV controlled, and it just sounds really nice. So we have Hastur over here, which is a module that gives you direct access to this vactrol component to use with however you'd like in your patches. And it gives you more control over things like the depth, the attack, and the decay, and hysteresis. Now we'll have another video that goes more into depth on how this specific emulation works from the engineers who actually, on the team who actually put it together. So stay tuned for that. And finally, down here in our patch, we've got MNMX or Eibon, which is a little slim, simple saturating mixer. So if you've got a lot of different inputs going into it, it'll give you a nice analog sort of warmth to the output signal. And I totally didn't forget to mention, we've got this beautiful blank panel right here, which has just got such a nice design on it. Pretty chaotic. That's sort of on brand. So here I am. So here I am getting some nice warm feedback by passing the output of the delay back into the MNMX. Love me that sound. Love it.
Well, thanks for coming, everyone. I hope you enjoyed your tour.
But there's still so much of the Madness Suite left to discover.
That's a good point. Well, perhaps as ever watching this, we'll just have to download it via the link in the description and give it a test drive.
And I guess subscribe to this channel so they don't miss future in-depth videos.
You're right about that. Bye-bye now.